Mars was not always cold. There was a time when rivers carved its surface, when lakes filled its basins, and when water flowed freely under a thicker sky. The planet we see today, dry, frozen, silent, is the aftermath of a long collapse. Nothing exploded. Nothing sudden happened. Mars didn't freeze overnight. It slowly lost the conditions that kept it alive. Its air thinned. Its heat escaped. Its water vanished not all at once, but piece by piece. As the planet cooled, seasons became harsher, ice crept toward the equator, liquid water could no longer survive on the surface. What once flowed began to lock itself away underground or drift into space. Mars didn't just change temperature, it crossed a point of no return. What remains today is a planet stuck in time, preserving the scars of when it was warm and the evidence of how it failed to stay that way. To understand Mars as it is now, you have to understand how a planet can lose its warmth without ever stopping its orbit around the sun. Early Mars was very different from the planet we see today. When Mars first formed, it was warmer and far more active internally. Heat from its formation and radioactive elements kept its interior molten for longer than we once believed. This internal heat-powered volcanic activity releasing large amounts of gases into the atmosphere. Those gases, carbon dioxide, water vapor, and nitrogen, built a much thicker atmosphere than Mars has now. With higher pressure and denser air, heat was trapped more efficiently. Sunlight that reached the surface did not escape easily back into space. This greenhouse effect allowed temperatures high enough for liquid water to exist. Rivers flowed, lakes formed, possibly even shallow oceans covered parts of the surface. Mars also had something crucial during this period, a global magnetic field. That magnetic field acted as a shield, protecting the atmosphere from the sun's charged particles. With that protection, the atmosphere could remain stable for long periods, instead of being slowly stripped away. Combined, these factors, volcanic outgassing, atmospheric thickness, and magnetic shielding, created a planet that could hold heat and support surface water. But this balance was fragile. Mars is smaller than Earth. It lost internal heat faster. As the interior cooled, volcanic activity slowed, the magnetic field weakened, and once that protection faded, the atmosphere became vulnerable. Mars didn't lose its warmth because it was far from the sun. It lost it because the systems that held heat together began to fail. What we see today is the result of that slow breakdown, a planet that once had the ingredients for warmth, but couldn't keep them forever. Mars didn't lose its warmth all at once. It lost its protection first. Early in its history, Mars had a molten active core. As the planet rotated, that liquid metal generated a global magnetic field similar to Earth's today. This magnetic field formed an invisible shield, deflecting the sun's charged particles and preventing them from directly striking the atmosphere. But Mars is smaller than Earth, and size matters. Smaller planets lose heat faster. Over time, Mars's interior cooled. As it cooled, the molten motion in its core slowed and eventually weakened. When that motion dropped below a critical threshold, the magnetic field collapsed. Once the magnetic field disappeared, Mars was exposed. The sun constantly releases streams of high-energy particles known as solar wind. Without magnetic protection, these particles slam directly into Mars's upper atmosphere. Over millions of years, they began stripping it away molecule by molecule. Lighter gases escaped first. Hydrogen drifted into space. Water vapor was broken apart. The atmosphere thinned steadily. As pressure dropped, Mars could no longer retain heat effectively. Liquid water became unstable on the surface. What remained either froze underground or escaped entirely. This wasn't a sudden catastrophe. It was a slow erosion. Mars continued to orbit the sun, unchanged in distance, while its environment quietly collapsed. The planet's surface preserved ancient riverbeds and lake basins, fossils of a time when protection still existed. Mars didn't become frozen because the sun changed. It froze because Mars itself changed. Once the magnetic field was gone, there was no way back. Without protection, the atmosphere could not survive. And without an atmosphere, warmth could not remain. That loss marked the turning point the moment Mars began its irreversible descent into the cold world we see today. Once Mars lost its magnetic shield, the planet entered a slow, irreversible decline. With no protection, The sun's energy began tearing at the atmosphere directly. Over millions of years, the air thinned. As pressure dropped, Mars could no longer support liquid water on its surface. Water became unstable. Some of it froze beneath the soil, locked away as ice. Some of it was broken apart by sunlight, hydrogen escaping into space, oxygen reacting with surface rocks, and some was simply lost forever. As water disappeared, Mars lost one of its most powerful tools for retaining heat. Oceans and lakes regulate temperature, they store warmth and release it slowly. Without them, Mars began cooling faster and faster. At the same time, volcanic activity declined, fewer gases were released into the atmosphere, the greenhouse effect weakened, each loss made the next loss easier. This was not a sudden freeze. It was a chain reaction. Less atmosphere meant less heat meant more ice meant less water vapor, and less water vapor meant even weaker warming. Eventually, Mars crossed the threshold. Liquid water could no longer exist on the surface at all. Even during warmer periods, it would instantly boil or freeze. What remained was a planet locked into cold, thin air, frozen ground, and a surface shaped by a warmer past it could no longer return to. Mars didn't die quickly. It faded. Today, it preserves that history like a time capsule. River valleys, delta fans, mineral deposits that only form in water, all frozen in place. Mars is not just cold because it is distant or small. It is cold because it lost the systems that kept it alive. And once a planet loses its water and warmth, time does the rest. What remains is not just a frozen world, but the record of how planets can change forever.